Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. In this session we will see how we can protect our oscilloscope from any damage, how we can set it properly for our testing, what are the basic safety steps that we must consider before any measurement using this oscilloscope. Either we are using CRO, cathode ray oscilloscope, or digital oscilloscope, or we are using any waveform recorder. We must understand some basics for these test equipments. Let's see it. When we work on electronic circuits, normally we deal with three types of circuits. The one that is battery powered circuit. It uses some battery cell, any source of battery that is not connected to main line. If we will test any signal from this board, we can test independently. We have no problem. So it is battery powered circuit which uses any positive and negative source, which is standalone source. Any signal high, low, we can test directly, no problem. This is our first circuit. The second circuit, that is isolated power supply. If we see this circuit, we apply line and neutral, and we have our transformer. This transformer will receive 220 volt at input, and it will provide output voltage, AC voltage, and its primary and secondary windings are isolated. In this type of circuit, the secondary winding is totally free from the primary. Secondary have no physical electrical connection with the primary. In secondary we will receive voltage, it will rectify, it will provide to this capacitor, and we will use this isolated supply to the circuit, and we can hook up oscilloscope for any measurement in this isolated area. Okay, it is safe. So it is isolated power supply. We apply line voltage to a transformer, and we take some voltage, then rectify it at capacitor. In this power supply, if we connect line, neutral, and earth, no problem. Secondary have no concern with this earthing point. Then the third stage, we have a power supply that don't have any transformer here in the primary side. We apply voltage to the fuse, then EMI filter. So this series filter, dual line filter, then these voltage are directly provided to this bridge circuit, bridge rectifier. We have line, we have neutral, and we have earthing point, ground point. So these line voltage are provided to bridge rectifier. I will skip all this circuit because it is just only filtration, but our line voltage are directly reaching to the bridge rectifier. These voltage are provided here. Then we have this circuit. We have chassis ground here. Positive, negative. Same here. We received positive, we received negative. But if we compare these two circuits, this circuit, we apply power in the primary, and the current flows in the primary, and it causes to generate a magnetic field which creates a voltage here in secondary. So our secondary is a separate source which have no electrical connection with the primary. So it is independent source. This circuit will behave like this battery powered circuit. Okay, we can test any signal here. If we see here, this positive peak will rectify through this rectifier and we will receive here. This negative peak will rectified and we will receive it here. Neutral line, negative peak will reach here, the positive peak will reach here, so we will receive a rectified line voltage at these two terminals. So if we analyze very carefully, we are receiving line voltage that are provided through our utility transformer, and we are receiving the pulsating DC voltage, but these are DC unisolated AC voltage or unisolated DC voltage, because if you don't have capacitor, these voltage are reaching here. Smoothing capacitor will make it DC and we will receive 330 volt, 220 here, 330 volt here. Then another type of circuit, line, neutral, earth point, and this is provided to a SMPS circuit, and then it will rectify positive, negative. It is isolated, but the ground, the earthing point is coupled here. So we have four types of circuits: battery powered, isolated, unisolated, isolated, and ground coupled. These type of circuits we usually repair in our workbench in any condition. Either it is SMPS, either it is inverter AC board, either it is washing machine board, either it is any type of electronic board which are in modern electronics, we deal with these circuits. Now we need to understand our oscilloscope, and then we will see how we can use it, and then we will see how we can protect it. This is our oscilloscope. We apply line, neutral, earth, ground. According to the manufacturer, we must connect the ground wire, line, neutral, and earthing point. For safety of equipment, we must connect it to ground. But when we deal with these circuits, how it will behave? Now, we apply power, it is ready to test any signal. And we have two test leads, high, low. This test probe, this is ground, low side, and this is high side. We can connect this to high, this to low, it will give inverted signal. If this is low, this is high, it will give direct signal in the positive direction. Now we must understand a very special hidden point in this oscilloscope. Any oscilloscope, set multimeter to continuity and verify that your oscilloscope have this feature. Connect to continuity mode. Connect to the ground point. So ground is directly coupled at test probe. If we see the second probe, the same here. If we see interconnection between this low and this low, it is same. And if we see trigger signal, if there is sync signal, trigger signal, every signal, all these low sides are connected to the ground point. So these are connected internally to the low side. This is a very useful point we must understand before using oscilloscope, otherwise we will damage the oscilloscope or we will damage the circuit card Now we realized that all the low side of test probes are connected to the ground terminal. This is for the safety. If you connect this oscilloscope to test any battery powered circuit, the high will connect it to high, low will connect it to low, and oscilloscope will display signal. If we will connect high to low, low to high, so it will display signal, the signal will inverted. Okay, no problem. If we test signal here, high to high, low to low, it will display the signal in the upper portion. Okay, if we reverse the leads, low to high, high to low, if you connect opposite cables, and it will display inverted signal. No problem, it is okay. The problem will start here. Now we need to understand it in more detail. We have our utility transformer which provides 220 volts, and its neutral side is connected to the earthing point, the local ground near the transformer. And when we apply line here, neutral here, and we create a local ground here to provide chassis ground to our device. Now line neutral, and here if we connect oscilloscope which is connected to the same supply source, line neutral, local ground, and we have test probe here, low side, and test probe here. Now if you connect high side to high, that will okay, because high side will go to any operational amplifier, any sampler circuit. But if you see the low side, signal low, when we will connect to this side, what will happen? The line will connected, the line voltage will come through this diode to the ground, and it will make a very big disaster. We can see we are connecting. Now if you connect this side with this one, what we will do, we will bring these 220 volt to this diode to the ground. Why? Because our ground is connected directly to this pin, and it have the same reference point, ground here, which is connected here, and the same earth, it is connected to utility transformer. So in this condition we will damage the oscilloscope, we will damage the probe, or we will damage the circuit. Maybe we will make damage inside oscilloscope, or maybe we will damage this circuit, or maybe we will damage this probe. This is the biggest point of safety while using oscilloscope for the live electrical circuits. Then we will see its solution, how we can cover this. Okay, the second scenario, if I connect high side to low, this high probe high side to the low side, and low side to the high side, the same, these voltage will flow to the ground. If I will connect between this positive point and the ground point, Between ground point and the input line terminal, there is just only one diode drop voltage. If you connect line voltage here, neutral here, so line and neutral will directly exposed to the ground through these diodes, because we are rectifying and we are providing and we are connecting ground to this terminal, so it will damage the oscilloscope or damage the circuit or damage the probe. When we will use it in this way, it will damage. And if we have isolated output like this one, the output is collected ground as in computer power supplies, we can test output signal without any hesitation. It will not damage anything because this ground will connect it to oscilloscope ground and it is safe. We will connect oscilloscope positive side, negative side, secondary side, not the primary side, secondary side. Secondary side we can test any signal with any configuration, high to high, low to low, no problem. That will save. The problem we will hear when we will deal with unisolated signal circuits. How we can overcome this issue? There are some solutions. The first solution for unisolated circuits, use battery powered oscilloscope. This is our first solution. So it is, although it is expensive, battery powered oscilloscope that is in double price than the regular oscilloscope. Then we can use differential probe. So differential test probes that are also expensive. The price of one probe will approximately equal to the price of oscilloscope. That will not a good decision. Then we can use isolation transformer. We can isolate this circuit. We need a very heavy size isolation transformer, because if you want to power up your test bench using isolation transformer, maybe you will need 5000 watt, 5 kVA, 6 kVA, 10 kVA, because when you are testing any job, you need isolation and you need heavy current based on the type of fault, maybe input short circuit. A small transformer will not be able to detect the fault. For that purpose, we can isolate DSO. You can use isolation transformer for our oscilloscope. So oscilloscope, the maximum power input that is. So our oscilloscope is not using too much power. It needs 100 to 240 volt AC, 45 to 440 Hertz, 30 watt maximum. So it is very simple. You can use 100 watt transformer. So that will very useful addition. What is isolation transformer? I am using my isolation transformer, 2-wire input, 2-wire output. You can use 3-wire input. You can also make a ground for isolation transformer, but I am using this transformer. Primary side, it have approximately 1.4 ohms, and if we test in the secondary, it is 0.6 ohms. And if we test isolation transformer with primary, it must open circuit, the second terminal open circuit. So this is our isolation transformer. I am taking 2:1 ratio transformer and it is providing me 115 volt AC. I am providing 2-wire input, taking 2-wire output. So I am not connecting the ground to my oscilloscope. Now I collected power. Now the second thing, When we say isolation transformer, you can use isolation transformer primary, secondary. You can use 1:1 ratio. 220 volt input, 220 volt output. Powering up just oscilloscope, use 100 watt, 200 watt, 300 watt. These are easily available in the market. You can use one. Or you can use 2:1 ratio. It will provide 220 input, 110 output. I am using this one. So it is helping me to use power up my oscilloscope, and also I can use 110 volt for different circuits. Then there is another type of transformer, that is auto transformer. Never use that one. That have just only one winding and it is center taped. 220 input, 110 output. These are also available in the market, so never use this transformer. Never use it. It is auto transformer. Use 2:1 ratio or 1:1 ratio transformer. In that case, we will just only allow to power on our oscilloscope. We will not connect to the safety ground. In this way we can test any circuit without any problem. Otherwise, if you connect ground, it will damage. We must see another safety. These are the possible causes. I am demonstrating just for safety. I connected 3-pin plug here, 3-pin plug here. This is to power up my power supply, and this is to power up my oscilloscope. This time I am not connecting ground, but what will happen when I will connect this test probe to any live circuit, for example this circuit, which is rectifying the unisolated voltage. These voltage will reach here to this ground strip, and it will also reach to this ground strip. So in this condition, when I will connect this low side here, and if I am not connecting anything, just only this ground will flow from the oscilloscope probe, and it will reach in this power extension, and it will reach to our all equipment which is connected to the same extension board. We can see while testing, while the probe is connected and this board is powered up, the line voltage will also appear in the chassis, other equipment which are connected to same extension board. To protect it from this issue, we can use 2-pin plug. If we are using to other equipment, that is the best solution. Remove this ground pin or use only 2-pin plug. That is the best solution. Or if you are using 3-pin plug and you want to use this oscilloscope also for ground signals, that time disconnect every item, every equipment which is connected to this extension. Otherwise, our line voltage will appear in the ground terminal and also the chassis of other equipment. If you are testing any unisolated signal, be careful. This ground terminal is directly exposed to line voltage. Never touch any ground terminal, never touch any probe. If you are connecting this probe here and you want to connect this probe and you will touch here, you will expose directly to this line voltage. Why? Because these low side probes are connected to the same pivot, the same point. It will become dangerous when it is connected to any test point which is unisolated, and if we touch this low side, or while adjusting, if we touch this connector outer shell, we are exposed to electrical voltage. We must be careful for these points. Use battery powered oscilloscope for unisolated circuits. Use differential probe. Second point, these are the expensive solutions. Use isolation transformer, that is useful addition in your test bench, and use a separate board for the oscilloscope. Just only take one socket, connect it to isolation transformer, and don't connect ground wire. If you are not using isolation transformer, just only take 2-pin plug and remove its grounding strip, or you can find 2-pin, or you can use these 2-pin plugs. Don't use the grounding pin, so it will protect your system. It will protect your oscilloscope to connect to the ground point. If you use 2-pin plug and we power up oscilloscope with direct line voltage, in that case line and neutral will reach in the oscilloscope power supply, and if you test any circuit at that time, it will not expose to ground and we will not damage anything. Use 2 wires power cable to power up DSO. This is also a solution. I hope so this video is informative. If it is informative, hit the like button. If you have any question, let me know in the comment box. If you have any suggestion, if you have any experience, if you have any guideline, please don't hesitate to write in the comment box. I will thankful and I will welcome your comment. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.